Hi everyone, welcome back. So let's discuss our problem for today from our SD sheet. We were discussing binary trees. I'll just quickly check if I'm live yet. Wait. I don't see myself live. Okay, we are. Okay, so let me show you the problem statement, which is this. You have to find the diameter of a binary tree. For that, you need to understand what is the diameter. So you are given a tree like this. For example, if there is a tree like this, the diameter of this tree is 3. How is it 3? What you need to understand here is that the maximum number of nodes you have from one leaf node till the other leaf node, which may or may not include your root node, which I'll explain you through an example. Let's check from here. Now if you see, if I take 40, I take 20, okay, how many nodes? 2 nodes, 10, 3, then 30. 4 nodes are there. From 40 is also one leaf node and 30 is also leaf node. So how many maximum nodes I found from in this path? It was 4. If I take path from 40, 20 and 60, it is also path from one leaf node till the other, but the maximum number of nodes in this case is 3. So I've already found a path which has more number of nodes in its path from one leaf node till the other one. If I consider this path can be any, you just have to find the diameter, which is the maximum number of nodes from one node till the other. And when I say from one node till the other, it's a 2 leaf nodes. Okay, so that's how you have to find it. Now if you observe this tree, one more example, let's see. So from here till this, okay, you are getting 9 number of nodes. That's what they are saying, 1 2 3 4 5 6 7 8 9. And if you see from here till here also, you're getting 9 number of nodes. For this case, let's say 9 is the maximum number of nodes you are finding from one leaf node till the other. The only difference they are trying to establish here is that in this path your root node is getting involved, but in the other path it's not getting involved. So that's the only difference they are trying to show, that your path could be anything which may or may not include your root node, but it has to be the maximum number of diameter is defined as the maximum number of nodes or the longest path from one leaf node till the other. Okay, so let us understand from example. If you have gone through previous videos, you must have seen how we calculate height of a binary tree. So if I take an example here, let me take this case. So if I take any tree, like, let's say this is 10. Okay, wait. 10, 20, 30, 40, 60. Now if I talk about this tree, okay, what is happening in this tree basically? See, at every node, what I am trying to check is that, for example, if I am at 20, let's say, okay, so if this is your entire tree, okay, so what should be the diameter? Obviously 3. So if I see, it will check what is the left height. So left height here in this case is 1, okay, so it will give you answer 1. Right height will also give you answer 1. Okay, so it will check from here also I'm getting 1, from here also I'm getting 1. What if I include myself also in that answer? Okay, so I will basically get the what is the maximum height, and I include myself in that answer will kind of give me the diameter. Okay, so basically it's left height plus right height plus I am adding myself. So at every node, what I'm trying to check here is that what is my left height, what is my right height, plus when I'm adding myself. So this is kind of giving me diameter for if I consider this as the only tree. Okay, so I am getting 1 diameter from here. This same thing I will check for the other nodes as well, and I will keep track of what is the maximum such path I am getting from any node. Okay, so let's understand it in this way again. Wait. So I have to actually calculate max of some, let's say, answer. I'm keeping a track of some answer which is storing the maximum diameter for any node. and I'm comparing it with, I must be getting some left height, I must be getting some right height, plus when I am considering myself into that path, so what is the total diameter that I'm getting? Is it greater than answer? Then obviously your answer will store this value. If it's not greater than your answer which is already present, then answer will have its own value which was there existing. So let's understand through this one dry run. Let's do it once again. Okay, so talking about this node, let's say, let me write a pseudocode here. For example, I'll directly write it this way, then we will understand. So you all know how we calculate the height of a binary tree. Let's take that example. For example, this is some function. Okay, this is some function which is taking your node root. Okay, so you know that if your root is null, your height is going to be 0, you return 0. Okay, then what do you check? You are checking what is your left height by making a call to this function and passing root dot left. Then you are finding the right height by making a call to this function root dot right. Now this is where you have to keep a check. You are every time storing your answer as max of answer, and what is your left height, what is your right height, plus you are adding yourself. So what is for that particular subtree, this is the diameter that I will get. Okay, left height plus right height plus 1, and the maximum will go into answer. But for the function, what you have to return is, you have to actually return the height, which is return. How do you return the height? How do you calculate the height? You find what is the maximum of the left height and the right height, the maximum of these two, plus you add yourself to return the height to the other node which has called you. So the return 1 plus max of left height and right height. Okay, you compare them. The maximum of these two plus 1 is what you return as your height. Now let's understand how is this working. So basically, see, this is my root node. Okay, this is my root node. I check, I make a call to the left one. Okay, left height 20, then I again make a call to 40. Right now I'm at 40. Again I make a call to null. Whenever I find a null, I get 0. I return 0 to 40. Same way I return 0 from right height also. What I have to return is 1 plus max of left height. So basically 40 will return 1 to 20 as its left height. Okay, so left height of 20 is 1 right now. So then I make a call to right height. I make a call to this function by passing 60 here. So 60 will also return 1 for itself, and this is returned as the right height to 20. Now, meanwhile, in my answer, I am calculating max of whatever is the left height, that is 1, plus right height 1, plus I am adding myself, which is actually giving me the longest path if I consider only 40, 20, 60 as my subtree. So you will see leaf nodes are 40 and 60, and the total distance, total number of nodes or the diameter for this particular tree is going to be 3. So basically right now my max has gotten its answer as 3, which is 1 plus left height plus right height plus 1, that is 3. Okay, so let's do our recursive call. So recursion is nothing but it's similar, completely similar to how we find height. Just an extra step that we have added here is that we are storing the maximum in one variable, which is actually at every subtree it is calculating what is going to be the diameter if I include myself in the answer for that particular root node of that subtree. So let's go ahead. Okay, so this 20 will return 1. Okay, return is 1 plus max of left height and right height. So max is 1 and plus itself, so 2 is what it will return to 20 as its left height. Got it? Okay, then 10 got left height is 2. Okay, now I will go and traverse the right height of 10. So right height will make a call to function by passing 30 into it. Then 30 will get 0, 0 and 1. So basically 30 will return 1 plus max of LH and RH. So LH and RH both are 0. So 1 is what 30 will return to 10 as its right height. Now during this task also I had to do this here as well. So when I was returning this, basically before this step, I stored answer. I stored in this answer max of answer was 3 right that time. Now for 10, what will I store in answer? That is, your current answer is 3. This is actually your answer. initially your answer was updated with 3. Okay, now you see, first before I return anything in my answer, I will update the value, which will be left height is 2, right height is 1, and if I include myself, it will become 2 plus 1 plus 1, that is 4. And if you observe what is the number of nodes I am getting, maximum diameter for this tree is, I should not say maximum diameter, maximum path from one leaf node till the other leaf node is 1, 2, 3, 4, and that's what it will update in your answer. So answer will be updated with 4, and then finally what I'll return is 1 plus max of left height and right height. So left height is 2, max of 2 and 1 is 2, and you add yourself. So finally the answer that I return is 3. But to my function, what I have to return is what I return to the function is 3, but what I have to return finally for this question is what value is stored in your answer. Okay, so finally you will return 4 as your answer. So again, let's take one more example. This is all about this question, but let's take one more tree. Let me take one bigger tree and then explain to you. For example, let me take one proved example. Wait, I'll take some example which let's say you have 10, 20, 30, 40, 50, 60 and 70. Okay, for example, this is the tree right now. How am I going to traverse through this tree? So you make a call for 10, then you go to its left height, then you go to its right height. Okay, so for 40 I will return 1 as the left height. Okay, try to understand the simple height function. Recall the height function. For that, if you have not done, you need to go to the finding height. I have taken that class, just go through it, you'll understand. So following that same logic, height, I am just finding out the height, making a call to height function. So 40 will return left height is 1, then I'll go and traverse, and 60 will return 1 to 50. From here it gets 0. Okay, then what happens is, see, here itself I have to take some step, I have to take some call, which is in my answer I will store the maximum. So you see, answer is storing max of, initially my answer is 0, left height is 1, right height is 0, and I'm adding myself. So this just tells me, for if I consider only 50 and 60 as my tree, so you know that it's a skewed tree, and the diameter in this case will be 2 itself, right? How many nodes are there in this path? Only 2. So answer will be updated with maximum of left height plus right height plus itself. So that will be 1 plus 1, 2. Answer has been updated with 2, but what you return is the height function. What you return in height function is exactly what we return to this function. So that will be max of left height and right height plus 1, which is basically 2. So this will return 2 to 20. So 20 is left height is 1, right height is 2. Okay, again you have to take some decision here to update your answer. So answer will see left height and right height plus yourself. Okay, what is the value? 1 plus 2, 3 plus 1 is 4. Is it greater than the current answer? Yes. So I'll update it with 4. And if you observe, if I consider only this, suppose if this was on my tree, so this is what kind of a tree is it? 20, 40, 50 and 60. So what is the maximum number of nodes between two leaf nodes? That is 1, 2, 3, 4, and exactly that is what answer is storing at this point of recursion call. Got it? Okay, now to the function, what I'll return is the height of this tree. So what height will this return? It is the 1 plus max of LH and RH. RH is 2, 1 plus 2, that is 3. So if you logically also observe here that why 3 should return, from 10, if you consider the lower part of the subtree after 10, in the left of 10, what is the maximum height? 1, 2 and 3 is maximum height which you are getting for 10's left subtree, right? So it should ideally return 3, which it is returning. Okay, let me just take it with different color so that you can understand this is the return value. Now we go to the right side of 10 and go further. So when I come at 70, this 70 will return 1 to 30, and you will see that answer will not be updated because 4 is the maximum. For 30, 70, the answer will be basically left height plus right height plus 1, that is 1, plus 0 plus 1 is 2, which is not greater than answer, so I won't update it. And what I will return is 1 plus max of LH is 0, RH is 1. So basically 30 will return 2 to 10 as its right height. So 10's right height is 2, left height is 3. Okay, again you have to take a decision before you return anything. Answer will update if I get LH is 3, RH is 2, that is 5, and I am adding myself also, so that will become 6. Is 6 greater than your current answer? Yes, it is. I will update my answer, and then finally my function will return the height of a tree. So height will be maximum of these two plus 1, that is 4. So basically my function will be returning me 4, but this is a separate function. I will make a call to this function from the function that my compiler has given me, and I will return what I have stored in answer. So finally 6 is what I should return for this particular tree, because that is the diameter of this tree. So if I observe how many nodes are there, maximum number of nodes between any two leaf nodes, so maximum is 1, 2, 3, 4, 5 and 6. That's all. On is the time complexity. You can see that simple. How do we calculate the height? We make a recursive function for finding the height. We have just added one extra step to keep track of our maximum in our answer, this variable. So this is just one extra step. Number of traversal on any node at max is once, so it is taking On of time complexity. So I hope you understood. If you have any doubt, let me know. I'm just checking your comments. Why 20 is returning 3? It should return 4. 20 is returning, see, 20 is not returning answer. What is the return of this function? This function is returning the height of the tree and not what we are storing in answer. Answer variable is only kept for the purpose of storing the diameter for that subtree in the recursive call. What function is returning? Function is returning the height of that subtree. You need to recall the height function. This is the reason 20 will return the height of that. So what will be the height if I consider only this as my only tree? So the height for this tree is 1, 2, 3. 20. How many nodes are there? 1, 2 and 3. So this is the reason that it is returning 3 to 10 as its left height and not answer. Got it? If you still have any doubt, you can ask me. Let's move to the code and I'll start code right meanwhile. By that time, if you have any doubts, you guys can ask me. Okay? So I hope you understood this thing. Let me just write it out. So, how do you make a call to your height function? Similar, exactly one extra line. If root equal to null, you return 0. Okay, then you keep track of left height by making a recursive call. Okay, before I do this thing, let's create one extra function, because I told you that function will be returning height and our answer will be stored in some extra variable. Int answer, let's take 0. Then int func, let me take helper or whatsoever you want to take helper, node root. Okay, so this helper function is actually is updating our answer but returning the height of the tree. It's nothing but the height function. Okay, let me write the height function. Okay, if your root is equal to null, you return 0. Otherwise, you make a call to left height by making a call to height function, and root dot left is what you pass, and int right height and is again how you calculate the right height by making call to the function by passing root dot right. And next thing what you do is that you are keeping a track of what is the diameter at that point in time. Recursively, when you are calculating at that subtree, what will be the diameter? So that will be updated in answer as math.max of what is the current value and left height plus right height, plus when you include yourself to get the diameter. So that will be updated. That will be just updated in our answer and it will be stored in our answer. What you have to return is height of the tree. And how do you return the height of the tree? By adding 1 to the math.max of what you get as left height and right height. Okay, so this is what you are doing, and here you're just making a call to this height function. okay, so that you can get the updated value in answer and return answer. Let's check. Capital M. Although the code is very simple, but you need to think a little bit. It might get a little confusing that why, like your doubt was there, why, what is the issue? Let me see, something's not working here. If root is null, root dot left, root dot right, max left height plus right height plus 1. Okay, this is by mistake, I wrote right height. Let's check now. Okay, that is done. So the doubt that you asked me is very genuine. A lot of time you get this doubt that Aman, you have asked me, why is it returning 3? Because you need to understand that this is nothing but your height function. Just to update the diameter, or this answer is nothing but just updating the diameter for that subtree whenever you are recursively making a call. So its only task is that, but your height function is returning the height of that subtree. Okay, this is the reason in that example what you were thinking, we were not returning that. Okay, so that was all for now. If you still have any doubts, let me know, otherwise we will wrap it up. Okay, fine, then let's wrap today's lecture. See you all in tomorrow's lecture. Bye bye.